A successful FTC season hinges on more than just a good robot. It demands a comprehensive season strategy that a lot of teams miss. If you want to avoid some of those common pitfalls and building up your team's performance, moving from just participating to genuinely contending in these competitions, then this video is for you. I'm Coach Pratt, and I've coached national champion FTC teams and Inspire Award winners. So I've seen what separates good teams from the mediocre. In this video, I'm going to run you through a strategic blueprint for your team's season. We'll talk about a guiding mantra for your season. How do you approach your judged awards? How do you talk about build season design, pitfalls and fixes, navigating some of those competition days, and then talking about strategic design in general for the season. Let's talk first about your guiding mantra for the season. This is the idea that you are going to follow throughout the entire season. That's common through line that everything has to come back to this engineering principle. And your guiding mantra is KISS. You know what KISS is? It is keep it simple, stupid. There's no comma in here. It is keep it simple and stupid. This comes from Kelly Johnson, aerospace engineer who created the first Mach 3 capable aircraft. And it's best exemplified from a story here, taken off of Wikipedia. Johnson handed a team of design engineers a handful of tools with the challenge of getting the jet aircraft that they were designed must be repairable by an average mechanic in the field under those combat conditions with only those tools. Hence, the stupid here refers to the relationship between the way that things break and the sophistication that's required to be able to repair them. If you start to get really advanced with your designs, they will likely fail. I always think back to Volvo's windshield wipers for their headlights. There is no need to add all of this complexity to a system. Keep it simple, stupid. Keep it reliable. Reliable robots win. If you find you're getting too complex in your system here, it's probably time to take a step back and look at, am I keeping my concept simple? Next, let's talk about awards. You've got the competition awards, and you've got some judge awards. For your judge awards, there's kind of three major categories here. You've got your Inspire Award. In order to be a contender for the Inspire Award, you have to be at least one of the top 6 in the machine creativity and innovation section or in the team attributes section. So effectively, you have to be a contender in design, innovate, or control. And then for your team attributes, you have to be a contender in connect or motivate. So that means you got to be one of the top teams in one of those 3 or one of those 2 categories. In my opinion, for these judge awards, well, one, you need to know what the judge awards are and what they're doing for the next season and how it is that you get them. So reading through that design manual as to what they are is really important. It's best to focus really hard on one of those 3, in my opinion. Maybe 2 in the MCI category, but maybe not in the team attributes category. Now, the reason I say focusing on just one of those 2 is it depends how competitive your specific region is. When we get to, say, the World Championships, it's going to be very challenging for you to be competitive in design and innovate and control all at the same time. Same thing, connect and motivate. It's going to be very challenging to be able to focus on all of them. Now, it's going to be a well-rounder, but really focus your time harder on one of those, and you might have more success, depending on how far you want to go. The Think Award, you need to be a contender in this regardless of what happens. And that's where your engineering portfolio really comes into key. You really want to show your engineering process. It comes back to what is the purpose of this whole FTC program. And one of the big purposes of it is to develop you as an engineer. So seeing your design thinking, seeing your design cycle over time is going to be really, really critical. They want to see that thinking. I would suggest in your portfolio that you even break your 15 pages that you get up, broken down by awards. Rather than having it a through line of your season throughout the whole time, you should have these 2 pages on connect, these 2 pages on motivate, these 2 pages on design, so on and so forth. And that makes it really easy and simple for the judges that are going through and reviewing your portfolio to say, okay, I know where the innovate section is. I know where the think section is. I know where the design section is. And then they can go through and score that rubric based on certain chunks instead of having to sort through everything. Because you got to realize these judges do not have a lot of time to be able to give you feedback on this and to be able to read your portfolios. So by hitting them over the head with, hey, this is design, it should make it really simple for them to be able to go through that rubric and assess where your team's at. As I was saying, with that Think and Inspire award, you have to be contender for multiple of those awards, including that Think. And one of the big things for that Think award is the robot design and game strategy. This talk today is all about how do you approach your game strategy. And remember that judges observe you both on and off the field when it comes time to these seasons. So moving on from those awards, that's kind of an opening frame. It's good to know your enemy before you go in, kind of Sun Tzu style. Let's talk about the design pitfalls and solutions that come into the robot design itself. One of the big ones is keeping documentation of your team's design. That can help you get that Think Award, showing why it is you're making those changes over time, showing the tests. I always go back to, you see there's a lot of tests and data on this channel. You can see across from 500, 1,000, 1,500 grams for some of my linear slide tests, things like that. How are you getting that data? What YouTube videos are you watching? You can use some of these as sources, as you can say, this is why we went with this design. One of the biggest pitfalls is trying to do everything at once. And when you're trying to do literally everything at once, looking at the game for the next season and thinking, okay, we need to be able to do this, X, Y, Z, A, B, C, D, E, F, your robot becomes half-baked and you really can't excel in one area. So for instance, when we look at the Into the Deep season, a lot of these robots were sample robots or they were specimen robots. It makes far more sense if you strategize on one way of scoring as opposed to trying to do both. Yeah, so get one objective really, really well. You want to say, pick up that sample all the time, accurately. Pick up the game piece accurately every single time. That's really important so that you continue to excel in that one area. So do one thing excellent rather than everything else haphazardly. A robot that is consistent beats things that are inconsistent. Great example of that is in Into Deep season. A lot of robots inside some of the seasons were simply push bots. They were just pushing around game pieces around the field. And because they could do that better than robots that were trying to do everything in that center stage season, they actually outperformed because they were consistent at that one job that they did. Again, coming back to that keep it simple, stupid. You overcomplicate the system, it's a recipe for disaster. You need to simplify. And some of those best designs are usually the simplest. The less moving parts, the better. The more moving parts you have, the more likely it is for something to break. You want to try to limit the degrees of motion that a mechanism itself operates in. Having a robot arm with 6 degrees of freedom is just 6 places that something can break. It's better to make a single mechanism that does 1, maybe 2 degrees of freedom to keep it simple. You also want to build for the shortest travel distance, so that straight line from A to B, and that can really help you solve some of that out. So when you look at the game, and when the game gets released, you have to think about, how can I approach this game piece? How can I get it from A to B in the shortest amount of steps possible? If you have to pick it up, bring that arm back in, transfer it to another arm, bring it back up, swap the arm around and then release, that's a lot of extra steps versus one arm able to pick up, transfer back, flip up, and then exhaust. That's already one less step and one less place for something to go wrong. Another pitfall is trying to come up with a scoring first as opposed to designing for consistency. This is the whole purpose of robotics. Robots are designed to be consistent machines. They can do the same thing over and over and over again. If you have a autonomous period that can score 5 samples sometimes versus 4 samples reliably, the 4 samples will end up winning just about every time. It's better to go for consistency over a Hail Mary, in my opinion, because it comes down to what is the purpose of robotics. Again, when you look at comes to alliance selection, you may have been a captain yourself or have maybe been trying to be picked, and you're far more likely to choose a team that is consistent over a team that has these wild swings because you don't know if you can count on them or not. So lower scoring points with consistency over time is far more important. Pitfall. A lot of teams run into build haphazardly and inadequate support structures. Things are leaning and flopping all over the place. One of the big things you need to do is you need to build for reliability. Make sure things are strong. Make sure they're rigid. Get rid of those single points of failure. Always have 2 points of contact if you're going to try to have something put together. If you're going to have linear slides put up, think about how you can add in some extra bracing to keep those things a lot more solid. If you're going to have a linear slide system to bring your system up and down, think about how you might have a second set for reliability just in case a wire fails or just in case you slip a pulley or something along those lines. So you need to think about what failures could happen and how you could work with that redundancy in mind. I would even go as far to say practice a little bit of driving with 3 motors as opposed to 4 motors in your drive wheel so that you can get used to what happens if I lose a motor in the middle of a match. So clearing up some of those consistent designs, let's talk about some competition pitfalls and some of the solutions that come along with it. One of the biggest things that teams fail to do is they neglect driver practice. And they drive around with a robot that they don't know, and they don't know if the robot doesn't work. The testing does not start until the wheels are on. And that is so important, I'm going to say it again. The testing does not start until the wheels are on. Yeah, because the learning doesn't start till those wheels are turning. And if you haven't actually tested whether your robot is functioning or not, you don't know if you're going to be successful or not. A lot of things work in theory, a lot of things work in code, a lot of things work in CAD, but does it work in real life? Real life is where things get messy. If you put me versus Max Verstappen, and Max Verstappen is in a Toyota Prius, and I am in a Formula One McLaren, there is no way that I am beating Max Verstappen in a race because he is the better driver. He may have a far worse car, but if he's a better driver, he's going to beat me 10 times out of 10 because he's familiar with what the car is doing, what that robot is doing. So you should have a few weeks of driver practice before leading up to a competition, ideally. Another pitfall when it comes to the actual competition is that their robot is fully driver controlled. So you need to lift up the linear slides. You need to move the claw out. You need to go grab the piece, then bring the claw back, then lift the arm back up, then release the claw. And each one of those is a separate button press. You should aim for partially automating some of your systems. So instead, when you push one button, the arm reaches out, it uses a claw to be able to grab, or it uses a camera to be able to know where a game piece is, picks up the camera, and then brings it back in. You should have some sort of sensor that verifies whether you've actually picked up a piece correctly or not. You should have some sort of automation that it lifts the linear slide up to a specific height every single time. So if you have a better strategy, you can likely pull off a win over a team that has a worse strategy than you. You want to have purposeful actions when you're designing this. How can your programmers make your driver's life easier? Well, this hasn't been as true in the last couple seasons. Being able to deny another alliance 10 points is the same as scoring yourself 10 points. So how can you drive defensively? How can you have some of those elements to stop other teams from getting points? Can also be beneficial. So strategic design for your full season. Designing a robot is cool, but one that performs well is even more fun. So cool robots, I'm a big fan of the rule of cool, but something that performs well is far more fun because it's competitive. You have to come up with a main aim for your team. And one of the hardest things to do is it's hard to build something and focus together a team if you don't have a concrete aim. And if you're not aligned as a team, it's really challenging to get there too. I like to use Jeff Bezos' strategy with Amazon, which is the disagree and commit. It is okay to disagree with where your team is going, but at the end of the day, you have to commit to a strategy. Yeah, the disagree and commit allows you to still maintain your own personal autonomy within that system, but you're committing to a strategy because it's better for the good of the team, even if it's a less optimal strategy. And sometimes be aware of that cool factor. A lot of teams try to make something look cool, but remember it's a team game. If you have your autonomous period and it's driving into your other teammates' line, you're not going to be as beneficial for helping out your team. First thing you need to do at the start of a new season is read the rules. Everyone on your team should read that manual. I know it's a long manual, but you have to read it. You have to examine as many ways as possible for scoring points, even some of those obscure ones. Don't just come up with the first idea that comes to your head. With my team, we spend 3 to 4 hours on that first night and the first week just only analyzing the game and thinking about how we can approach it. We don't do any building for the entire first week because it's all brainstorming and ideation. Another thing to look at is how can you stop your opponents from scoring? They're good to have in the back of your mind, but this is not a primary focus. You want to focus on how you can be scoring. Make sure you understand your ranking system. This changes from year to year. I'm not going to talk too much about this and how you get forward because it might change in your season for next year. Another thing to think about is there is some sort of chokehold strategy. So if you can do this one thing, can the other team not eke out a win no matter what it is that you do? And for each of these, after you've done analyzing this game, you have to think about what is the time sunk for this. If I put this much time into this, what is the reward I'm going to get out of? If I put this much time into it, what else is that award going to get in? And remember, it's not just about role building, it's also about the award. So it's about a half and half. It's half how your robot does in the field. It's also half how you can describe and make your thinking visible. So obviously, the best tasks are things that take the low time cost with high points. And sometimes denying your points 10 points is you winning 10 points because if they're not getting 10, you're automatically getting 10 on that benefit. Once you're done analyzing that game, make it a priority list. What are the things your robot has to do? Speed, power, agility, center of gravity, however these are. What kind of qualities do your robots want? What kind of functionalities do they have to do? If you look at center stage, you have to be able to place some pixels and game pieces on an angled piece. You have to be able to climb yourself up and do some robot chin-ups. You have to be able to shoot airplanes. And then decide on what your drive system is going to be and what your kind of main chassis design is going to be based off these priority lists. If you need absolute speed, if you need more agility, if you need more power, it might change how you do that driving system. So, for example, if we were to start with the priority list on center stage, that was the 2022-23 season. First priority is just the ability to move. If you can move, you can push some of the game pieces around, and just pushing game pieces into a corner scores you points. That's priority one. Get a robot that can move and push. Then get something that can acquire and release. Doesn't necessarily have to be high or any certain point. You had to pick a game piece and you had to put it back up on this kind of angled platform. So if you can pick something up, that's another big one. Then priority 3 is just to be able to perhaps score, but at a low point in value. So you really have to grade these out and build robots that can do these tasks as you go by. Do not try to do everything all at once. Let's come back to some final thoughts on simplicity and some golden rules. First golden rule, always build within your team's limits. You have to know where your team is at with realism. You have to be pragmatic here. There's people, there's budget, there's experience, there's skill level, and time. Time is an engineer's biggest enemy and friend. You have to know how much time you have to realistically do this. This may not be an optimal mechanical component, but if you can continue to iterate on your mechanics, you now give your programmers less time to program with that new mechanism. And when your programmers have less time to program, your drivers have less time to practice as well. And some of these things cause ripple effects. Yeah, so having 3 functions that do it 10 out of 10 times versus 5 functions, put it 6 out of 10, will win every time. Not every time, but it is far more likely to win, to be able to be reliable in that respect. Now, there's no shame in having a simple robot. One of my favorite examples of this, I can't say a simple robot. One of my favorite examples of that is sort of a lo-fi prototyping. There's a Litbot at the 2024-25 season, and their robot was almost all made out of wood. They did have some complex mechanisms, but they used some very simple strategies to be able to be reliable over time. So teams that try to do more than they're capable of tend to fail. But it comes off with some trade-offs. Yeah? So try to maximize the functionality with some simple add-ons. You want to iterate over time. You don't want to have these brand new ideas every single time. So is it possible to score using your intake instead of having to transfer it to another device that scores? That's generally preferable. Sometimes when you're doing this, it can be hard to change one component without modifying everything else down the line. So having a less components and less mechanisms really helps and comes back to that initial priority list. Always refer back to it. And you may need to update your priority list over time, but that is your guiding mantra throughout the season. One of the biggest things that I can tell you is that skipping directly to design and implementation is a recipe for mediocre design. If you skip the iteration and the brainstorm session, you will likely fail and you'll probably have a mediocre design. Remember your training from all of your design classes. Use your design cycle. There's a reason we spend so much time in the empathizing and defining your key design constraints, because if you don't know what your target is, you're always going to miss. So make sure you know what your key priorities are. Make sure you know how you win and score points in this game. Make sure you know all the different possible, or not, you can't say all, a large variety of ways that you could solve this problem using that brainstorm so that if something fails, you can come back to another idea. And oftentimes teams think that spending so much time brainstorming is a waste of time, but it comes up with many ways of approaching that solution. Got to be realistic when you're valuing some of these. I mean, we look at elite teams in those 2 minutes when they're driving, that teleop, maybe 9 to 15 cycles underneath perfect conditions. So mid teams are going to be 4 to 6. You got to be realistic. And remember, you got to partner on these teams. You can lean on them for some of these tasks. They don't have to do everything. So here might be a priority list that I've come up with for doing the center stage season. Get a functioning base chassis that can push pixels into the pits. You get 6 points every single cycle when you do that. Have some sort of autonomous mode to be able to park. get 10 points for that. Some sort of simple hanging mechanism to suspend your robot, 20 points. Autonomous mode that can place another game piece, 20 points. Consistent airplane launching, 10 to 30. And then some sort of intake and exhaust for pixels, 5 to 10 points a cycle. It depends on how many people you have on your team. You may want to swap some of these priority lists around. But having some of these has your potential for getting a lot of big points pretty early with some relatively simple designs. Another thing I'm going to leave you with is the idea of modular design. You want to be able to have multiple team members ideating on multiple versions of different prototypes and having that iterative design so that you can have some competition internally to learn from one another. You'll always be able to come up with a design that may be better. It also allows you to have 2 different linear slide design setups, and then you can just add and bolt on these systems as they go on, rather than having to take apart your entire robot. So at the end of the day, keep it simple, stupid. Yeah. Remember what Kelly Johnson said. You do not want to overcomplicate your design. That is so important. Testing doesn't start till your wheels are on. You have to get functioning, minimal, viable prototypes. You could have a beautiful CAD design, but if it doesn't work, you've just spent hours CADing something out that is a failure in real life. So keep it simple, stupid. Best of luck with analyzing your game this season, and I hope to see you out there on the competition field.